Hello and welcome to a new episode of Library of the Week. Today is our 10th episode, and since this is a milestone for this series, I'm going to be doing a bit different. Instead of talking about one big project, one big library, I'm going to talk about 10 small Python libraries that we can use as data analysts. As usual, this is part of a Medium series I do about Python libraries. In the description of the video, you can find the Medium article I wrote about these 10 fantastic libraries that we can use as data analysts. So let's begin. The first library I want to talk about is called LatexifyPy. This allows us to create LaTeX-style equations from Python functions. It is important that the Python function is some kind of mathematical function. To use it, we just have to import Latexify. We define a function, and with the latexify.function decorator, we will be able to get the LaTeX representation of the function. In this case, my function is the sum of a and b, and this is how it is represented. If I print the sum, it returns this expression, and this expression is LaTeX. And LaTeX, in case of you don't know, is a kind of old technology that allows to create very good looking reports. And when you use Markdown many times, you can use some LaTeX expressions. So for example, to write this in Markdown, I just have to write double dollar signs before and after my expression. And see, this is how it's written. So as data analysts, this can be pretty useful because sometimes we need to express how we did what we did, but not in a code style way. And this is more readable to people without programming skills, but that still need to understand what kind of mathematical operations we may have performed. You see, I made this equation up just putting a whole bunch of symbols. This doesn't really mean anything, but it's just to show that you can actually do any kind of complex mathematical function and express it the LaTeX way. The second library I want to talk about is clean text. This library allows to clean some text to do further analysis on it. We import it with the statement from clean text import clean, and I have a text string here with spaces, uppercase letters, extra spaces here, non-ASCII characters like the E with the accent or the U with the accent, and I can transform this string with this clean function and assign it to this new variable called clean text test. I can set to true or to false a lot of optional parameters like lower. In this case, this will return everything lowercase. And the replace with only works, of course, if you had the equivalent or the corresponding parameter set to true. So for example, replace with emails. If no emails is set to true, then every email will be replaced with this string here, and you can set whatever you want. And see, we print the new clean text test chain after we cleaned it, and all the unnecessary spaces have been removed. Email has been replaced. The email has been replaced by this email statement. Everything is lowercase, and so on. Just to go a bit further, I imported the whole Bible here in as a text format, just because I thought this was a very long text. So here I just printed the first 50 characters to see that everything has been imported. And now if I clean it, let's see how long it takes. This is about 6 seconds. I used time it to test it. So yeah, it's about 6 seconds. And if I get the first 50 characters like I did before, see, in this case, the word God has been put to lowercase. The next library I want to talk about is word cloud. This is a Python library that allows us to create word clouds, which is a graphical representation of the words that come more often, that are more repeated, that are more frequent in a Python string. It is not mandatory, but it's recommended to use it with matplotlib. If not, you can use it with pillow. I have a test string where the word test is repeated more often, 3 times, and I import word cloud like this. From word cloud import word cloud, and I use word cloud.generate test because test is my variable. And here I have the word cloud with the word test bigger than the others. I'm sure you have seen this kind of representation before. And since I imported the Bible earlier, let's do that again. And let's make a word cloud of the Bible to see how this looks and how long it takes. So it took about 3 seconds, and here we have the most repeated words of the Bible. You can do it with any text that you want, and I think this is pretty cool. And you can actually use this kind of graphical representation in your data analysis reports. The fourth library I want to talk about is TQDM. This is just a progression bar that you can use when you're working with Jupyter notebooks, and it comes in pretty handy because many times we do repetitive tasks or tasks in loops, but we don't know how long it's going to take. In this case, I import time too, so this is to make the test and to see how the progression bar is going to behave, and I import TQDM, as you see, and I use the TQDM function to wrap. In this case, it's my range, but it can be any iterable that you're going to use to loop over. And you see the progress bar takes longer as it goes because of the task we're performing, which is dividing I by 10, where I increases in this range of 20, and well, it represents some time. The next library I want to talk about is SweetViz. This generates automatic reports, their HTML reports, with exploratory data analysis for your data frames. I'm going to start by importing pandas and creating a pandas data frame from an iris data frame that I have downloaded from the internet. Everything is linked in the description of the video if you want to get all the data. And then I just need to import SweetViz and use the sweetviz.analyze and my data frame. And I have to also use the show HTML to generate the report. Let's see what happens. It takes a little bit of time, not that much. And boom, here it is, my data frame summarized. The next library I want to talk about is GeoPy. This library is a client for several services, so it's like a wrapper with a W, not wrapper as a musician, if you can call it like that. So you need to import it like this from geopy.geocoders, import, and in this case it's nominatim, but you have other services that you can use. Check the documentation. Again, everything is linked in the article and in the description of the video. I create a geolocator object with this nominatim function that we just used. I need to give it a user agent, but it's whatever you want. It's not like an API key or anything, so in my case I called it medium test, but whatever, this is just a name you give it. And you need to give it a location. In this case, I use Bergerac. It's the city where I live, but you can use your address. I was not going to put my address, obviously. It can be any address, in fact. Once that you give the location and save it in a variable, you can get the latitude and longitude of the place as well as the address. So let's see how this works. So you see, in this case, Bergerac, it detected that it's in Dordogne, which is the French department, which is an administrative division, and Aquitaine, which is the region France Métropolitaine, this is mainland France, 24, this is the zip code, and France, the country. The latitude and the longitude. So this comes in pretty handy when you have data from towns or places in your dataset and you want to work with geographical information. It's really neat. Now if I just test here, I put, for example, Madrid. It's so see it gives the content in Spanish this time. It was French before with Comunidad de Madrid, España. But let's imagine that we are in Madrid. I think there is a Madrid in Mexico, for example. You will get the one from Spain. So you have to be careful sometimes the place that you may be looking for. If it's named like some other place, be careful with what you can get like this. If I put Madrid, Mexico, in this case, I get the Mexican Madrid. I have to be more specific. Now I want to talk about XLSX Writer. This allows us to create Excel files with Python, and we can also use it with pandas, and this is pretty neat. This is the part we're going to be seeing, because in this series I assume that these are 10 libraries for data analysts, and if you're a data analyst working with Python, there is 99% of chances that you are working with pandas, at least some of the time. There are other great libraries, of course. So let's re-import the iris data frame that we imported before, and we can use the Excel writer function with pandas. It is important in the engine parameter to pass the XLSX writer and give the name of the file that we want to create. So this is LibreOffice. I opened the file we just created. For now it's empty. Okay, we just initialize it, so it's empty. And to fill it, what I'm going to do is get data from the iris data frame that we just created, and instead of passing everything to one sheet of my Excel file, to make the example a bit more interesting, I'm going to put each species of the iris data frame in a different tab or worksheet. So for that I separate in 3 pandas data frames. So I get the Setosa, the versicolor, and the Virginica species in different pandas data frames, and I use the toExcel function to pass to the writer object. So the writer object is this object that we just created before with the XLSX writer, and each time I give it a sheet name, so Setosa, versicolor, and Virginica, and at the end I close this writer object. And now this is how my iris dataset.xlsx looks. I have Setosa, versicolor, and Virginica in different tabs. The next library I want to talk about is PyPDF. As data analyst, it happens that we need to get data that is stored in PDF files, whether it's PDF files that have been generated by other BI tools in the company but that we don't have access to, or PDF files that are generated by other companies or organisms that we find online or that they transmit to us. Or it can also be old files of the company of 10, 15 years ago, and they had different tools back then, but we still need to get data from those reports. Whatever the case is, it can be pretty handy to have a way to read that PDF. Just a disclaimer, this doesn't work if the PDF that you have is like a scanned image. For that you would probably need OCR or something like that, but it's way more complicated. In my case, just for the test, I downloaded the Universal Declaration of Human Rights by the United Nations. So I think this is copyrighted, but for the example we're going to do, it's actually okay. Let's not read it too much. I import PDF writer from PyPDF. I create a reader object with the PDF report I just showed you, and let's see how many pages this has. It has 72 pages. Now the thing that is a bit annoying, but it's easy to overcome, is that PyPDF will let you read as Python strings the content of each page of the PDF. So you have to specify what page. So in order to get the whole report, we have to iterate over all the pages. I create an empty string to append each page one after the other, and I loop over the range of the length of all the pages. In order to get the text or the string as a Python string from a particular page, I use the reader.pages function, and I give the page number. This takes a little bit of time. I should have used TQDM. Oh well. And here it is. The document has 14,000 characters. And now that I have them all as a Python string, I can do any kind of analysis, word clouds on it, or whatever I want. The ninth Python library I want to show you is called Data, and this is also a great one. We're going to start by creating a pandas data frame, our famous df iris data frame, and we are able with detail to create a kind of worksheet that opens in the browser. I create, first of all, I import detail. I create a D object with detail.show. I give the data frame as a parameter, and I use the open browser function, and let's see what happens. So this actually takes a little bit of time. I cut the video a little for this. Here I have my data frame in a worksheet format, and you see we can do plenty of analysis. So we can filter values. Let's say I want the values greater than 5.5, and so all my sepal lengths are greater than 5.5 now. You can create heat maps for your values. You can create charts as well. Lots and lots of things. I think the best thing is that you download it and you check it out because it's really great. Now this is, I would say, less powerful than Microsoft Excel, but this is a very, very great tool for exploratory data analysis to get a good overview of your data. So I really recommend it. This is a great, excellent tool I discovered not that long ago, and I cannot but recommend. The last library I want to talk about is Faker. Faker helps us create synthetic data. Sometimes it's hard when we're working on projects to get simulation data, and accessing production data is not only is it not always easy, it's most of the time not really allowed or a good practice to do. So you just need to import Faker. From Faker import Faker. You create a fake object. And once that you have this fake object, you just have to use the many methods it has. So you have fake.name, fake.address, for example. And in this case, Max Campbell lives in this made-up address. And every time you use it, it gives you a different fake data element. You can use the seed to block it and to always get the same fake data, if that is what you need, or you can use it in a loop, and since it's random, it will, and if you don't have the seed blocked in your loop, of course, you will get a list of different names, addresses, or any other fake data that you can need. I suggest you go see the documentation and see all the methods that Faker has. And that was it for today. I hope you liked this special edition of Library of the Week. If you like this video, please consider subscribing to the channel and click the notification bell. If you have any comments with libraries that you would like me to talk about, or any other kind of content that you could be interested in, please leave a message below. And until next time,